Welcome to all in this lecture. This is the fourth lecture in the series of beams, and in this lecture, we are going to see an example on the beams. So, before starting, you need to know the equilibrium conditions to solve the examples on beam. So, what are the equilibrium conditions? The first condition is the summation of moments at any point on the beam. At any point on the beam is equal to 0. The summation of forces on x-axis is equal to 0, and the summation of forces acting on the y-axis is also equal to 0. These are the three equilibrium conditions. Using these three conditions, we are going to solve the questions. So let's start. This is our question. Determine the reactions developed at the point A, B, and C. Okay, this point is A. Here is the point B. Which point? This point. This is the B point, and this is the C point. Okay, it is A, this is B, and this is C. Okay, now let's start. Let's analyze the beam first. See here, at point A there is a hinge support. This is the symbol of hinge support. At point B there is a roller support, and at point C there is no support but a 2 kilonewton force is acting on the C in vertically downward direction. So what does we came to know from this? We come to know that as the last support is at point B, the part BC is a overhanging part, because at point C there is no support. Hence this total part is a overhanging part. Okay, now see here, this is a 5 kilonewton per meter force is acting on part A to B. We have to convert this 5 newton meter. Into a point load. So, as it is acting over a distance of 8 meters, see here, from point A to point B, the distance is 8 meters. So we will assume that the total force will be concentrated at 8 by 2, that is L by 2, that is 4 meter. That is from point A and from point B at 4 meter distance, the point or the concentrated force will be applied. So now the question arises, what will be the magnitude of the force acting at the 4 meter distance from A and B? To know that answer, we need to find the area of this rectangle. So how we will find the area? Length, we will assume the length to be the intensity of the force, that is 5u, into this 8 meter into 8, that is W into L is the magnitude of the force, that is 5 into 8, that is 40 kilonewton. That is at the 4 meter distance, that is this is 4 meter and this is 4 meter. At the 4 meter distance, a force of 40 kilonewton will act. Okay, this is our first conclusion. Now, as this is a hinge joint, a horizontal force in the direction of beam will be acting on it, and a vertical force will be acting on point A in vertically upward direction, and a horizontal force in the direction of A. Okay, these two forces will be reacting, and also it is given that a anti-clockwise movement of 10 kilonewton meter is acting at point A. This much data is given, and as at the point B, sorry for disturbance, as at the point B there is a roller support, so a vertically upward perpendicular force will be acting on point B. Okay, and from B to C the distance is 3 meters. So let's draw a free diagram from it. See here, Here the force RH is acting at the point A in horizontal direction. Okay, because this is a hinge support. This is a hinge support. A vertical, perpendicular vertical upward direction RV force is acting on point A because it is a hinge support. On point B there is a roller support, so RB force RB is acting in a perpendicular upward direction at the point B, and 2 kilonewton of force is acting on point C in perpendicularly downward direction. Okay, now see here, there was a 10 kilonewton meter for moment. 10 kilonewton moment was acting on point A. Here we have represented the same. Okay, and now there was a uniformly distributed force of 5 kilonewton per meter was acting on span A to B. So 5 into 8, that is W into L, equal to 5 into 8, that is a 40 kilonewton force is acting on a point. What will be the distance of point from A to B? That will be equal to length, that is span, into half, span upon half, that is 8 divided by 2 equal to 4 meters. So from point A and from point B the distance is 4 meter to the point. Okay, this 40 kilonewton meter is acting at the center of A to B, that is from 4 newton from both the points, and there is a 3 meter distance from B to C. Now first of all we will take the condition summation of moment at point A equal to 0. We can take also summation of moment at point B equal to 0, or summation of moment at point C equal to 0. That is completely upon you. So let's start solving. We have taken summation of moment at point A equal to 0. Now see here, first of all, here the moment is in anti-clockwise direction, so it will be minus 10 kilonewton meter. So we have taken here minus 10. Now also we know that this is a 40 kilonewton force in perpendicularly downward direction. So at this point, if we visualize this force, it will be in clockwise direction. It will be in clockwise directions. And what will be the magnitude of the moment? 40 into this distance, 40 into 4. See here, we have written plus into 40 into 4. Now again, at this point RB, a force is acting in this perpendicular upward direction. So moving toward the point, it will be anti-clockwise. So it will be negative. And what will be the moment? Moment will be RB into the distance from point A to point B. The distance is 4 plus 4, that is 8. So here we have written minus RB into 8. And now at the point C, there is a 2 kilonewton force acting vertically downward. So moving towards the point A, it will be in clockwise nature. It will be in clockwise nature. Hence it will be positive. And 2 into the distance between point A to point C, that is 8 plus 3, that is 11. Okay, see here we have completed the equation. Minus 10 plus 40 into 4 plus 2 into 11 minus RB into 8. After completely solving this equation, we get RB is equal to 24 kilonewton. What we have got? RB equal to 24 kilonewton. Okay, now we will consider summation of force at acting on x-axis equal to 0. So see here, in this condition only RH is acting on x-axis, only RH is acting on the x-axis. So we will get summation of Fx equal to 0. And what are the forces acting on Fx? It is only Rh, positive or negative. It is positive, Rh equal to 0 we get. That is Rh equal to 0. So what does it mean? It means that the support here at the point A is not hinge support. It can be a roller support, or it can be a simple support, but it is not a hinge support. Why it is not a hinge support? Because the RH element, RH force is equal to 0. RH force is equal to 0. Now moving forward, now we will consider summation of Fy equal to 0. Summation of Fy equal to 0. So see here it is Rv. What will be? It will be positive Rv because it is upward. See here, it is 40 Newton moving downward direction. So minus 40. There is Rb in upward direction. So plus Rb. Okay. And 2 kilonewton in downward direction. So minus 2 kilonewton. And what do we know? The value of Rb is equal to 24 kilonewton. So we will put in it. So see here. In this equation, we get Rh equal to 0. And for this, Rv is 0 equal to Rv minus 40 plus Rb minus 2. So we get Rv equal to 18 kilonewton. So that is how we solve the examples on beams. Thank you for watching this video. In the next video, we are going to solve another examples. Thank you for watching.